Hello everyone. Good evening, all of you. Just tell me in the chat whether my voice is audible and whether my video and screen is visible. Please confirm in the chat, everyone. Okay. So thank you for confirming. So let us start with today's session. So today's session is going to be conducted by Rohit sir, who is going to take up with latest, or you can say the pseudocode questions which are asked by Accenture in their previous exams. Okay, so these questions which are going to be conducted today, these will be the actual questions asked by Accenture in the exam. So actual questions will be asked. So you'll get an idea about what kind of questions Accenture asks. So basically, we are going to do this video series for Accenture and other companies as well. So Accenture has nearly 6 sections in its test and a coding section. So total 7 type of questions you can say, or 7 sections, and each section has got different type of questions. So we thought about giving you an idea about what kind of questions are asked in each section of Accenture. Okay. So this will give you a good idea about the type of questions, what is the level of difficulty, and what is the level of teaching which Talent Battle conducts, what is the quality of training which Talent Battle conducts. Because if you like the way our trainers teach, then you can definitely join our Accenture Cracker course, and we are starting with the live batch for Accenture Cracker course from 13th of July. So it will have extensive preparation for Accenture, right from all the previous year questions of Accenture of all sections, including the coding round as well. Okay, so without wasting much time, I would just ask Rohit sir to start with the session. And later on, guys, if you have got any queries regarding Accenture Cracker course or any other query regarding Accenture, you can always get in touch with us. So Rohit sir, over to you, and you can start with the session.
Okay, sir. So students, just confirm once, am I audible and clear? Okay, great. So now, as Amit sir has said, in our today's session, we are going to conduct previously asked pseudocode questions for Accenture, which will definitely going to help you understand the way, the type of questions that they are asking, and what are the important topics that you should prepare. Whenever we are talking about the pseudocode, it is important to understand the flow of that particular code. In most of the cases, they will clearly specify the statements which are inside the loop, the statements which are inside the conditional statements, and where the loop is going to get end, where the conditional statement is going to end, and what exactly the value that we have to return. So important thing is you should analyze the given question properly, and then whatever the values they have provided, according to that, calculate the final answer and select the best one which is provided in the options. The questions mostly based on the looping structures, conditional statements. Bitwise operators are important. In most of the questions, you will see the utilization of bitwise operators are done. Then some questions based on array and recursive functions. These are the some important topics. After doing the analysis of previously asked question, that I can say, if you practice this, it will be easy for you to solve the pseudocode questions. Now we will actually start with the questions. And I would request that you should also parallelly try to solve it and put the answer in the comment section. And then after explaining it, you can confirm once. So the first question, what will be the output of the following pseudocode? So just analyze the steps which are provided to us. Integer a, comma b, comma c means 3 variables are there of integer type. Set A is equals to 6, B is equals to 2, and C is equals to 9. Means the values are provided to us. The value of variable A will be 6, B will be 2, and C will be 9. After that, we have to calculate the C based on the provided expression. That is C is equals to C plus A plus B. Now I will just use the same values what they have provided and we will calculate the updated value of C. Make sure that whenever you calculate a value for a variable in upcoming statements, use that updated value. Now C is equals to 9 given to us, plus A is equals to 6. So 9 plus 6 plus value of B is 2. So calculate this, it will give me 17. So value of C is 17 right now. After that, there is a loop for each C from 2 to 4. Now, what is the meaning of this particular statement? They are giving us the instruction that this loop is going to get execute for the value of C from 2 to 4. Means C is equals to 2. This will be the first iteration value. C is equals to 3, second iteration, and C is equals to 4, third iteration. So when C is equals to 2, after that C is equals to 3, and then C is equals to 4. These are nothing but the number of iterations. And in every iteration, we have to calculate this expression. A is equals to 4 XOR 10. Now, these are the bitwise operator that they have used. So there is an XOR operation between 4 and 10 plus value of B. So we have to calculate the A value in all three iterations. So let us do it for first where C value is equals to 2. A is equals to 4 XOR with 10 plus B. Now we know bitwise operators are working on the bit positions. So we need to first calculate the binary for 4. So binary for 4 will be 0, 1, 0, 0. And binary for 10 will be 1, 0, 1, 0. Now according to the truth table of XOR, if both the inputs are 0 or if both the inputs are high, means 1, the output will be 0. And the alternative inputs if we have according to the XOR truth table, that is 0, 1, 0, 1 combination. 0, 1 or 1, 0 combination, the output will be 1. So when both are 0, the output will be 0. 1, 0, 0, 1 combination is 1. 1, 0 combination is 1. Again 0, 1 combination is 1. Now this is the representation of 14 in decimal format. Means 4 XOR 10 is going to give me 14 plus value of B is given to us, that is 2 is equals to 16. So at the end of the first iteration, we got the value of A is equals to 16. Now again, next iteration when the value of C is 3. Now if you observe, to save the time, because pseudocode questions are time consuming questions. So if you figure out the pattern over here, it will be easy for you to save the time. If you see the value of C, whatever it is, the expression is not going to consider the value of C. Only A value has been calculated based on the fixed XOR operators and then the value of B. So that is not going to get changed. Means in every iteration, you will get the same value for A. A is equals to 16 when C is equals to 3 as well as C is equals to 4. Right? Now my for loop completes and outside the for loop, we have to print the value of A plus B. So final output will be A plus B. The latest value of A, that is 16 plus value of B we have already given, that is 2. So final answer will be 18. And you can see option number D is the correct answer. Got it? This is how you have to deal with the provided questions. Yes, Sachin. In most of the cases, they will try to give you a lengthy pseudocode and some of the operations will not work, like dependent on the result of the conditions. So they are just for time consuming process. So try with the next question now. Question number 2. Here bitwise AND operator is utilized. What will be the output of the following pseudocode? Again, 3 integer variables are given P, Q, R. The value of P is provided as 9. Value of Q is 5. and value of R is also 5. Now we have to calculate P according to the given expression. After that R and again R. So two expressions are given for calculating the value of R. And after that we have to print P plus Q plus R. So P is equals to R, that is 5, and this is bitwise and not logical and. Then value of Q again 5. Again perform the AND operation with respect to value of Q, that is again 5. So we'll solve this. The binary representation of 5 is 0101. Again we have to perform the same AND operation on the same value. Now according to the AND operation, if both are 1, then the output is 1, right? Otherwise it will be 0. So we got the same result when we perform 5 and 5. Okay, so this is 5. Again AND operation with the 5 means again we are going to get the same result, 5. So P will be 5 at the end of this expression. Then calculate the next value R. R is equals to value of R, that is 5. Again AND operation with 5 and again AND operation with 5. Means again it is similar to what we have done for P. So again you will be getting the same answer for R, that is 5. Then again calculate the new R according to the third expression. So R is equals to Q plus 5. Value of Q is 5 plus 5 plus value of Q again, that is 5. So Q is already given to us, which was not utilized or which was not getting modified in the earlier two expressions. Only P was getting modified and R was getting modified. So 5 plus 5 plus 5. Let me just recorrect this. P is equals to 5 we got. Then R is equals to 5 and 5 and again and 5. So that will be 5. So value of R will be 5 plus 5. That is value of Q and plus 5. So 10 plus 5 is equals to 15. So R value updated, we got 15. And now what we have been asked, print P plus Q plus R, right? So P plus Q plus R, value of P is 5 plus value of Q is 5 plus value of R updated is 15. So the final answer will be 25. Yes, option D again. Let's move to the next question. Now this is lengthy. Multiple for loops are given to us. Now there is no bitwise operators utilized. Just based on the value that they have provided for P, Q and R, we have to solve this. So go step by step. It will be time consuming, but make sure that you are considering the updated values that you have calculated. Otherwise, the answer could be wrong one, right? Now, the value of P is given to us, that is 5. The value of Q is given to us, that is 4. And value of R is 9. So first I will calculate the value of R, that is R plus P. So 9 plus 5 plus 9 again. So this will give me 23. So value of R is 23 right now. After that, for each R from 2 to 3, right? So for this iteration, each R is equals to 2. We have to calculate these two expressions, and then when R is equals to 3, means two iterations are involved here. When R is equals to 2, I am calculating P is equals to Q plus 7. Value of Q is 4. 4 plus 7 plus value of P, that is 5. So this will be 16. Updated value. Then calculate the next Q. Q is equals to Q plus P. Current value of Q is 4 plus updated value of P is 16. So we got Q is equals to 20. Then second iteration, when r is equals to 3. Again, calculate p is equals to the updated value that we have to use, 20 plus 7 plus 16 is equals to 27 plus 16. That comes out to be 43. So p is equals to 43. And q is equals to q plus p. Updated value of q is 20 plus latest p update is 43. So that will give me 63. So updated value is q equals to 63. Now this for loop is completed and for is also mentioned. Then again you are calculating p. So for this expression, again calculate p, q plus 3. So 63 plus 3 plus 63. That gives me 129. So the latest updated value for p is 129. Clear? So half of the problem is solved now. Then one more for loop is there, which is ranging from 5 to 7. So for every value of r, which is starting from 5, then r is equals to 6 and r is equals to 7. 3 iterations are involved. Again, we have to calculate the value of p and q. So p is equals to 6 plus 11, that is 17, plus latest value of q, that is 63. And the final addition will be 80. Then calculate the q value also, that is p plus q, 80 plus 63, that gives me 143. In the second iteration, when r is equals to 6, my p calculations are 6 plus 11 plus q is equals to 17 plus latest value 143. That gives me 160. And value of q will be p plus q, 160 plus 143. And that turns out to be 303. Then when r is equals to 7, the third iteration, value of p will be 17 plus 303. That gives me 320. And value of q will be p plus q, 320 plus 303. That is 623. Iteration completes. And then they are asking us to print the value of p plus q. So latest updated value for q is 623 and latest updated value for p is 320. So final answer will be p plus q, that is 320 plus 623, which leads to 943. And 943 is present in the option A. Yes, correct answer from students as well. So let's move on to the next question. What will be the output of the following pseudocode? Integer j and m, where the value of m is set to 0. Now this is array based question. The value of m is initially set to 0. An array is given to us with 4 elements. So if I represent this array in the structure where I can represent indices. So first value is 10, then 11, then 3, and then 2, where indices will start from 0, 1, 2, 3. Now for each j from m to m plus 3. Now see, value of m is set to 0, means we can mention this as 0 to 3, right? So again, how many iterations will be there? J is equals to 0, first iteration, j is equals to 1, j is equals to 2, and j is equals to 3. Means 4 iterations we have to consider. So when j is equals to 0, then j is equals to 1, j is equals to 2, and j is equals to 3. 4 iterations. Now check the condition of if. If the condition is true, you have to solve this expression a of j is equals to a of j minus 1 plus 2. If not, then next iteration. This is how the structure is given. Now when j is equals to 0, if I check the if condition here, 0 greater than 0, this is false. Means in my first iteration, there is no modification for the value of a of j. Then move to the next iteration when j is equals to 1. When j is equals to 1, 1 is greater than 0, which is true. And we will calculate a of 1 is equals to a of j minus 1. And j is 1. 1 minus 1 means 0. Means a of 0 plus 2. Now we know that when we represent this a of 0 or a of 1, we are actually targeting the value present at that particular index. Now which value is present at a of 0? 10. So 10 plus 2, this will give me 12. Now my a of 1 is modified and this is 12. Go to the next iteration when j is equals to 2. Again check the if condition. 2 is greater than 0. This is also true. Calculate a of 2 is equals to a of 2 minus 1 means 1 plus 2. What is a of 1? 11 plus 2. That is comes to be 13. Means a of 2 is equals to 13 now. Then next iteration, 3 is greater than 0. This is also true. So a of 3 is equals to a of 2 plus 2. A of 2 is 3 plus 2, that is 5. Means a of 3 is equals to 5. Clear? Now my for loop completes. After that, they're asking us to calculate the value of m based on the updated a of 0, a of 2, and a of 1. So m is equals to a of 0 plus a of 2 plus a of 1. Whatever is updated, that we will use. A of 0, no modification, so that will be 10 plus a of 2, we got the modified value, that is 13, plus a of 1 also we got the modified value, that is 12. So what will be the final answer? 10 plus 13 plus 12. Sorry, one mistake from my side. I have to consider the updated value which I have calculated in the previous iteration when j was equals to 1. So instead of considering a of 1 is equals to 11, I have to consider it here as 12. And due to that, my a of 2 will become 14. This is going to happen if you are not considering the updated value. So this will be 12 plus 2, and that is 14. And here also, I have to consider this a of 2 as 14. And 14 plus 2, this will be 16. So my a of 3 will become 16. And now you calculate the updated value. A of 0, 10. A of 2 is 14 plus a of 1 is 12. And that turns to be 36. So final answer is option C, 36. Yes, Aniket, got your point. We need to consider the updated value. I have considered while calculating the old one, means the previous value which was provided in the question, but we are modifying it inside the case. So it will be the updated one. Now the answer will be 36. Move ahead with the next question. Here XOR operator is also there and AND operator is also there. What will be the output of the provided pseudocode? Integer value P is equals to 8, then Q is equals to 2, and R is equals to 5 is provided to us. Now multiple conditions. If the condition is true, we will target this expression. Otherwise, we will target this expression. After that, we will calculate the value of R. And based on that, again, if the condition is true, and then finally we have to print P plus Q plus R, right? So first condition I am checking if the value of P plus Q minus R. So 8 plus 2 minus 5 is less than 3 minus 8. So 8 plus 2, 10. 10 minus 5 is 5. 5 is less than minus 5, which is false. Means control will go to else block. Now in the else block, I am calculating q is equals to 7 plus q, which is nothing but 7 plus 2. So my q will become 9. If block completes, then I am calculating r. R is equals to 2 and 11 plus r. So we have to again go with the AND operator bitwise. So for binary of 2, it is 0, 0, 1, 0, and then 11. It will be 1, 0, 1, 1. Perform AND operation. That will give me 0, 0, 1, 0, which is nothing but 2. So 2 and 11 is 2 plus R value. That is 5. So R will become 7. Again, check the condition. If R minus P means 7 minus 8 is less than P plus R means 8 plus 7. So 7 minus 8 is minus 1, which is less than 15. So this turns out to be true. So if condition is true, we have to calculate the value of Q. Value of Q is equals to 12 and value of R, which is 7. Updated value we have calculated here. So again, perform the bitwise AND operation. So binary for 12 will be 1100, and for 7 will be 0111. Perform the bitwise AND operation. It will give me 0100. This is totally dependent on truth table logic. So this turns out to be 4. So this will be 4. So updated value of Q is 4 now. Now they have asked us to print P plus Q plus R, final result. So latest value of P, that is int, because not of expression has not modified that value, plus latest value for Q is 4 now, plus R will be 7. So that will be 19. So answer is option D. Okay, Aniket, I will explain that part, how to convert to binary. There is a simple trick for this. You have to consider the values like 1, 2, 4, 8. If I specifically talk about the 4-bit binary, okay, then the number that I have to achieve means the number for which I am considering the binary, make sure that addition of this will give me the same number. Suppose I want to go for 12 and I want to calculate the binary for 12. So 8 plus 4 will give me 12. Now, so the bit position for these two digits I will set to 1 and other will be 0. So this is the binary for 12. Suppose I want to calculate for 7. So 4 plus 2, 6 plus 1 will give me 7. So I will keep this 0 and this 3-bit position will set to 1. So this will become the binary of 7. This is the trick. And again, this will give you the bits position up to 15. If you want to go ahead, then you can increase this sequence. This will save your time. In the same manner, calculate for 11. It will be 1011. 8 plus 2, 10. 10 plus 1, 11. So those numbers which are providing me the addition as 11, I am setting the bit value to 1, remaining 0. So this is 11. Like this. This is the way where you can easily go with the binary representation. And you should be very clear with the truth table values. Okay. So AND truth table, OR truth table, XOR and NOT. These are the 4 major operators that we use. How after 15? Yeah, how after 15 you can increase this table. Now after 8 it will be 16, right? Then 32, like this. But in most of the pseudocode cases, up to 15, majorly up to 15 they will ask, but you can continue with the same trick. Okay, so the answer for this question is 19, option D. Move ahead to the next question. Question number 6. Again, an array based question, but here logical AND operator is utilized, 2 times ampersand symbol. So question says that integer value m, whose value is set to 0, array is given to us for 5 elements. Then if condition is checked for the position of p of 0, logical ANDing with p of 4. And if that is true, the value of m will be p of 1. Then next, if condition is checking p of 2, logical ANDing with p of 3. If that is true, the value of p of 2 will become the value of m. And at the end, we have to print the value of m. So the array p of 5 is given to us with 5 elements, 1, 1, 0, 1, and 7. Now to solve this question, okay, to solve this question, we should be very clear about the logic of logical ANDing. Logical AND is the operator which works if the expression 1 and expression 2, if this expression is also giving me true results and this expression is also giving me true results, then the final answer will be true. It's like our bitwise truth table. If both the inputs are 1 means true, so it will give me true, otherwise it will be 0. Any of the expression is false, the final answer will be false. But if the values are taken instead of expression, suppose I am taking 1, logical ANDing with 1. So 1 is represented for true. Any other number apart from 0, positive number, is considered to be true. And if 0 comes, then it will be false, right? So if I am using 1 logical AND 1, the final result will be true. And if I am using 0 logical AND with 1, then it will be false, because one expression is false. So entire result will be false. Okay. This logic we will use here. Now the array is p of 5 is equals to 1, 1, 0, 1, 7. If condition, first if condition says p of 0. What is p? I will write down the indices also. 0, 1, 2, 3, 4. P of 0 is 1. Logical AND with p of 4. P of 4 is 7. Both are positive integers. Means this is also true and this is also true. Means the entire result is true. When entire result is true, the condition is true. So value of p of 1 will become the value of m. So m is equals to p of 1 and p of 1 is 1. So m is equals to 1. Okay. Then next if, in second if, we are taking p of 2. P of 2 is what? 0. Logical ANDing with p of 3, that is 1. Now here this is false. 0 means false. 1 means true. So final relation will be false. As the condition is false, this expression will not execute. M is equals to p of 2. The value of m will not change. It will be 1 only. And then we have to print the value of m. So m value is 1. So answer is option B. Got it? This is how you have to work with the basic fundamentals. If your basic fundamentals are clear, easily you can solve this question. So pseudocode is actually easy. It is time consuming, but if you are aware about looping structures, conditional statements, arrays, and bitwise operators, then easily you can work with the pseudocode round. Let's move ahead with the next question. Question number 7. What will be the output of the provided pseudocode? 3 variables again, pp, qq, and rr. So pp value is set to 3, qq value is set to 5, and rr is set to 7. For each r, again loop comes. So for rr, when it is 4, and rr when it is 5, means 2 iterations. 4 to 5 means 2 iterations. When you are calculating for 2 iterations, I am calculating pp is equals to current value of pp, that is 3, plus current value of qq, that is 5. So this will give me 8. So value of pp will be 8. And qq we have to calculate again. Qq is equals to 11 and 7. Again, the truth table, bitwise AND comes. So calculate according to the logic. So I will calculate 11. The binary representation for enable will be 1011. And for 7, it will be 0111. So if you take the AND, it will give me 0011. And this is nothing but the decimal 3. Means the value of 11 and 7 will be 3. Plus we have to add the value of QQ. So this is 3 plus QQ value is given to us, that is 5. So it will become 8. So updated value of QQ is 8. This is the end of first iteration. Again, perform the second iteration. Again, PP is equals to current value of PP, that is 8, plus latest value of QQ is 8. So that will give me 16. So my PP will become 16. Then second expression, QQ is equals to 11 and 7. Now that will be same, no change. So that is again 3 plus QQ, updated value 8. And that will become 11. So now my updated value for QQ is 11 and PP is 16. After the for loop is completed, we are calculating again PP is equals to 2 bitwise AND with PP. So PP is equals to 2 and current value of PP, that is 16. Now again, go with the binary representation. Now here see the number which is greater than 15 comes. So binary for 2 is 0010. And now as it is greater than 15, which is 16, so we can add one more bit here, which will be 0 for 2. And for 16, it will be 1000. And the same operation of bitwise AND. And this is going to give me 0 only for all the cases, because there is no positive input in both the input cases. So this is 0. So 2 and 16 will give me 0. So the updated value of PP will become 0 here. After that, they are asking us to print the result PP plus QQ. So PP plus QQ is equals to 0 plus latest value of QQ is 11. So final answer will be 11, option A. Yes, correct. So most of the students are giving the correct answer. That is very good. Sakshi, it is mentioned in the for loop that for every RR, it is iterating from 4 to 5. So first value will be 4 and second value will be 5. So that's why 2 iterations will be there. Got it? Now move to the next question. Question number 8. Now here recursive functionality is utilized. As I mentioned earlier, there will be some questions based on recursive functions also. So analyze the question carefully. What will be the output of the following pseudocode for value of A, which is equals to 4, and value of B equals to 6? The function is given, which is accepting 2 parameters, A and B, that is given 4 and 6. And inside the body of the function, first if condition says, if the value of A is greater than 1, we will return this, A multiply by. And this is the recursive call to the function with updated values, but they have changed the sequence, B and A. So this will pass control here. If this condition is true, it will continuously going on, recursive calls. Otherwise, we will come to the else block and return 1. So this is my best condition. After that completion, we have to return A plus B at the end. Okay, now see how it goes step by step. First, we have a definition of a function which accepts 2 integer parameters, that is A and B. And there is an if else condition also, which is checking that A is greater than 1. Then the function will recursively call itself with the updated values. And what will be the updated values? A will become now B minus 6. Sequence is important here, parameter sequence. First parameter will always go to A. Second parameter will go to B. So A is equals to B minus 6 and B is equals to A minus 4. and then whatever is the value returned will be multiplied with the value of a. And if a is not greater than 1, then the control will go to else block and we will return 1 from here. Apart from that, we have to return a plus b. Okay, now let's evaluate this based on the provided values. A is equals to 4 given to us and b is equals to 6 given to us. Now in the first call to the function, a is equals to 4 and b is equals to 6. Check the condition if 4 is greater than 1. Yes, definitely it is true. So we are going to return 4 multiply by. Now see, whenever the recursive function is getting called, the intermediate result, because it is not a complete statement, it will call that function till it is executing. So in such cases, the recursive function will maintain a separate stack memory and which will store this intermediate result unless and until you reach to the base condition. And then it will recollect all the result and then final answer will be written. Okay. So 4 multiply by the function call with the values b minus 6. So now the value of a will become 0 because 6 minus 6 will be 0, comma. Second parameter is a minus 4. Value of a is given to us is 4. 4 minus 4 is 0. Means a and b has now become 0. Now you again call this function with the updated values of a and b and you check the condition. For this is the expansion of function 0, 0. A, which is 0 now, is greater than 1 and this turns out to be false. And when this is false, control will go to the else block and it will return 1 from here. So we are returning 1 from here as a result of this function call. And this return is 4 multiplied by 1. Reverse, we are calculating all the intermediate result. And this turns out to be final result 4. So the output will be 4. Got the answer? So this is a function call, na, actually. See, when you are executing the if block, this will return the value. If block is false, you go to the else block and it will return 1. So it will recollect those results and it will return from the function. Yes, Ritik, correct. Yes, Aryan, that is what I am saying. When the else block will execute, na, the control will directly transfer from return 1, which will recollect all the previous results, and that is 1 multiplied by 4. Yes, if you assume that the values of if means first if condition is false at the very first instance, then you will go to the else block and final answer will be 1 because it will return 1 from there. Yes, Aditya, I will explain that. Recursive functions are the functions which are calling itself. So based on the new updated parameters, you have to calculate the function again based on the provided code. Now in our first attempt, we have the value of a is equals to 4 and b is equals to 6. So we check the if condition, and as condition was true, we go inside the if body block and we return a multiply by one more function call with updated value of a and b. That is 0, 0. B minus 6 is 0 and a minus 4 is also 0. Then my if condition is false, control goes to else block and it will return 1 from there. Okay, great. Let's move ahead to the next question. Question number 9, the second last one. What is the output of the provided pseudocode Here also XOR as well as bitwise and both operators are utilized. So given values, A is equals to 7, B is equals to 3, and C is equals to 4. First, we have to calculate the value of B. So B is equals to A plus A again is equals to 7 plus 7, which gives me 21. So value of B is 21. Then again for loop. For loop says each C value from 5 to 7 means 3 iterations are there. So for C is equals to 5, we have to calculate A is equals to 11 XOR value of B is 21. 11 XOR 21. So let's calculate the binary. 11 is represented as 1011, but 21 we have to represent with respect to 5 digits, 5 bits. So I will add 0 for 5. And then 21 binary will be 16 plus 4 plus 1. So it will be 10101. And we have to perform XOR operation. According to the XOR truth table, if the inputs are in the combination 0, 1 or 1, 0, the output is 1, otherwise 0. So 1, 1 is 0, 1, 0 is 1, 0, 1 is 1, again 1, 0, 1, and 0, 1 is 1. Now calculate the decimal based on the position, and this is nothing but 30. So 11 XOR 21 is giving me 30. A is equals to 30. 16 plus 8 plus 4 plus 2, that is 30. This is I'm using 1, 2, 4, 8, and 16. Now we got A is equals to 30. Again, next iteration for C is equals to 6. Again, calculate the same, and it is the same value because C is not involved in that expression. So 11 XOR 21 will again give me the same. That is A is equals to 30. And similarly for C is equals to 7 also, I will get A is equals to 30. Means at the end of the for loop, my value of A is 30. After that, we have to solve this expression. A is equals to C value. C value is 7 now updated. And there is bitwise and with 1. Again bitwise and with the value of B. B value is 21. Now again binary representations. So binary for 7 is 0, 1, 1, 1. Then binary for 1 is 0, 0, 0, 1. This will give me 1, 0, 0, 0. And this is nothing but 1. So 7 and 1 is 1. And 1 and 21 we have to perform again. So for 21, we have the binary. So if I represent 1 in 5 bits, it will be 0, 0, 0, 0, 1. And 21 in 5 bits will be 1, 0, 1, 0, 1. Again, perform the truth table of AND here. This will give me 1, 1 as 1 and other combinations will be 0. Means the final result will be 1 again. So 1 and 21 will be 1. So A is equals to 1 at the end. Now they are asking us to print A plus B. So value of A is 1 plus value of B is 21. So final answer will be 22. And that is option D. How C is equals to 7? It is mentioned in the for loop, right? Harsh? That my for loop will go from 5 to 7. So C is equals to 5, one iteration, C is equals to 6, second iteration, and C is equals to 7, third iteration. So after third iteration, we got the value of A is equals to 1. And then we calculate A plus B. So it will be 1 plus 21 is equals to 22. Yes, Tejasvi, correct. It is mentioned from 5 to 7. So we have to check for 5 also, 6 also, and 7 also. So the last question now, question number 10. Again here, recursive functionality. What will be the output of the following code where the value of A is 8 and the value for B is 2? So value of A is given to us, that is 8, and value of B is 2. Inside the function, there is one if condition, which is based on logical and. If the condition is true, we have to execute these two expressions, and then we have to return the function call with the updated values of A and B. After that, we have to calculate the new value of B based on this expression and then return A plus B. Okay, so check the first if condition. B, which is 2 less than A, that is 8, logical and 4 is greater than B value, that is 2. Now 2 less than 8, this is true. Logical and with 4 greater than 2, this is also true. Means both the expressions are true, means final result will be true. As the condition is true, we will go inside and calculate the updated value for B and A. B is equals to 1 plus 1 plus A. What is the value of A? 8. So that will give me 10. So value of B is 10 now. Then calculate A. A is equals to 2 plus 1 plus B. Latest value of B is 10. So that will be 13. So value of A is 13. Now we have to return a function call with the parameter 13 comma 10. See, now A and B we have calculated now. So this will pass control to the function again with value of A is equals to 13 and B is equals to 10. And again, you have to check the condition. Now for this function call, we will check the condition of if B value is what now? 10, which is less than A value is 13. And now here itself 10 less than 13 is true. Second is 4 greater than B value, that is 10, and 4 greater than 10 is false, means the if condition is false. Control will go outside if, and we have to calculate this expression now. So B is equals to B plus 2 plus B, which is equals to 12 plus 10, and that is 22. Latest value of B is 10. 10 plus 2 is 12 plus 10, that is 22. Now we got B is equals to 22. A is already having with us, that is 13. So these are two updated values. Then return A plus B. So 13 plus 22, that is 35. So option C is correct. Got it? Yes, almost everyone has given the same answer. So that's it for the today's session, guys. I hope you like it and it was fruitful to you. All these questions are previously asked questions. As it is, we have considered them. So that will help you to understand what kind of questions they use. So as I mentioned, recursive functions, array, for loops, if-else condition statements, and bitwise operators. These are the major things. And if you want the similar kind of pattern, or we are also working and we are starting a new batch from 13th of July specifically for Accenture. So you can join the batch, and definitely I'm waiting for you, and we will solve all such questions as well as coding also. From technical perspective, parallelly, we will conduct aptitude as well. So over to you, Amit sir. Any doubt if you have during these questions, you can just put it in the chat box.
Yes, sir. If you are done, we can end the session.
Yeah, done, sir. Thank you.